Hi folks, Vivek from Exam Victor here. In this lesson I'd like to talk about some basics in ratio and proportion. Now this video is an introduction, it's an introduction to this topic. If you have some exposure to ratios and proportions, if you are from a maths background, then you can probably skip it. But if it has been some time since you've touched this subject, then it's a good idea to watch it. Alright, so first of all, what is a ratio and what is a proportion? You'll always see that in any book or any area where they deal with this topic, you'll always see ratios and proportions together. So what are these? First, let's look at a ratio. A ratio is something that is written like this. It is a way of representing a fraction. Okay? It's a way of representing a relationship between two quantities. So if you say 2:3, you can also write it as 2/3. It's not wrong to write it like this. This is not the literal interpretation. What it means to say that two things are in the ratio 2:3. For example, if you say apples and oranges are in the ratio 2:3, then what that means is for every 2 apples there are 3 oranges. So that's why a fraction would make sense some of the time, but not always. It just is a way of representing a relationship between two different quantities. If this is a bit confusing, don't worry. I'm just trying to explain the theoretical base. We'll see in the following slides how we should use this in questions. Alright. So what a ratio is, to summarize, a ratio is a relationship between two quantities. Okay. If that is the case for ratio, then what is a proportion? Proportion is like a larger relationship than a ratio. Proportion is saying that the relationship between two quantities is in the same order as the relationship between two other quantities. Okay. So what we have here is a trivial example. We'll see what proportion is actually used for in the next slide. But this is a trivial example, 2:3. These 4 colons are called is as. Alright, so 2:3 is as 10:15. Just the colon is called is to, and these 4 things, the 4 dots or the double colon is called is as. Not really important, just letting you know, because I'll be speaking this in questions when we are solving. You don't really, it's obviously not going to be asked in the exam. So 2:3 is as 10:15. It's just saying 2/3 equal to 10/15. We can check this. 2/3, if you multiply this by 5 into 5, so 2 into 5, 10, 3 into 5, 15, so it's the same fraction. Okay, so that's a proportion. In this format, not so useful. In this format, okay. Proportions are very useful in a different format, which we'll see in the following slides. Okay. The beauty of proportion or the usefulness of proportions is when you know, let's say there's a proportion called A:B is as C:D. Okay. And let's say in this proportion, you know A, you know B, and you know D, and you want to find out the value of C. That's when proportion comes in really handy. So because you can always write A by B equal to C by D, you can simplify this to equalize C equal to AD upon B, and then you can solve for C, right? So proportion is very, very useful when you know 3 and you want to find out the fourth. So when you know 3 and you want to find out the fourth, then you can use a proportion. How do you remember this? How do you simplify this for solving in the exam? So this A:B is as C:D. If you keep this in mind, what you can remember is that the product of these two, the outer two, is equal to the product of the inner two. So AD will be equal to BC. Okay. If you remember this, you're good. You remember this, and then you will be able to solve many questions in the exam where you will either not know C. Typically, you'll either not know C or D. Let's look at a live example. Okay. So a live example for this would be, let's look at the exchange rate, right? So let's assume that $1 is equal to 50 rupees. Alright, $1 is 50 INR, and you are going to the US, okay, and you want to arrive at US with $200 in your pocket. Okay, so when you land at the airport in the US, you want to have $200 in your pocket. So you're wondering, how much money should I pull out from the bank in India? Like how much rupees should I convert to dollars? This is a classic, beautiful example for proportions, right? So what you're being asked basically is that $1 is to 50 rupees. So $200 is to how many rupees? Fine, you can just say I'll multiply, but the thing is you're applying a proportion here when you're multiplying, right? You're trying to find out this value, and you know that the product of these two is equal to the product of these two. So this value is basically this value into this value into divided by the first value, right? So this is equal to 50 into 200 divided by 1. That happens to be 10,000. So you know you should go and pull out 10,000 rupees from the bank to arrive with $200 in your pocket when you reach the US. Right? So this is an example of proportions. Right, so before we wind up, some two very common and very useful tricks to solve questions. You may or may not already know these, but if you don't, it's good to know them. First trick is, many times you'll see three things in ratio, right? That's why I said a ratio is not always a fraction. You can't always write a ratio as a fraction because a ratio is actually a relationship. Many times you'll see three things in a ratio. What do? The first thing, the best thing to do is to say that those things, just add an x in front of them and just say their values are 5x, 7x, 9x, as in this example. So let me take another example. Let's say the question says that animals in a zoo, alright, animals in a zoo, and let's say the kinds of animals are, we're talking about donkeys, monkeys and pigs, alright. So the animals in a zoo, there are three types of animals. So you have donkeys, monkeys and pigs, and there in the ratio 3 is to 8 is to 11. Okay, so 3 for donkeys, 8 for monkeys, 11 for pigs. So there in the ratio 3 is to 8 is to 11. Before you even read the next sentence of the question, you can already, in fact you should already just put the values of donkeys equal to 3x, monkeys equal to 8x, pigs equal to 11x. Only then will you start even solving the rest of the question. This works every time, very reliable. It's a good trick and it saves a lot of time when you're solving a question. What is this? What is this x thing that we have done? Why does it even work? See, it works because x is some constant which I don't know the value of, but it obeys this relationship that these three quantities have to be in the ratio 3 is to 8 is to 11. All I'm saying is I don't know the actual number of donkeys, monkeys or pigs. All I know is that whatever that value is, the three values will obey this relationship 3 is to 8 is to 11. So if I multiply 3 is to 8 is to 11 by some constant x, then I will get that value. And I hope to get that value when I'm solving the question. Many times you don't get the value and it's fine. Sometimes you do because that's the whole point of the question. The question might ask how many monkeys or how many pigs. In any case, what I want you to take away from this page is this x trick. Okay. If you see three things in ratio, 99.99%, just add x in front of them and then start solving with that. It will make your life simpler. It will make the solution faster. Alright. Another useful trick in ratios. Sometimes, this doesn't happen so often, but sometimes you'll get a question where you have to combine two ratios. Maybe an example could be that ratio 1 is maybe the ratio of 25 paise coins to 50 paise coins, right? And maybe ratio 2 is the ratio of 50 paise coins to 75 paise coins, if such a thing exists, right? 50 paise to 75 paise, let's just assume. So ratio 2 is the ratio of 50 paise to 75 paise, and ratio 1 is the ratio of 25 paise to 50 paise. And for whatever reason, you are looking for one common ratio, which is something is to something is to something, as one ratio for 25, 50 and 75 paise coins. So how do you do this? The way you do this is to make this thing, the thing that is common among these two is the 50 paise, right? And 50 paise in this first ratio is 3, in the second ratio is 5. So you have to find a way to make these both the same. The way you do that is by multiplying this by a certain number, this by a different number, so that this digit becomes the same. Obviously for 3 and 5 it's very simple. You're looking to make them both 15, right? So you multiply ratio 1 into 5 and that becomes 5 into 2 is 10 and 5 into 3 is 15, so it becomes 10 is to 15. Multiply ratio 2 into 3. So 3 into 5 is 15 and 3 into 7 is 21. So now you have both of the 50 paise coin digits as the same. So now you can write this as one common combined ratio as 10 is to 15 is to 21. You can write this ratio. So this is another useful trick. This, I won't say it's very common, but when it does happen, knowing this trick saves some time, right? So knowing this trick is useful. Otherwise, this was overall a basic introduction to ratios. This is Vivek from Exam Victor. Thanks for watching.